Hi, I'm Andrea and welcome to Productive C#. In this video, I want to show you my Advent of Code Day 4 solution in C#. Day 4 is all about bingo, effectively. The input is a list of numbers that will be drawn, and then you have a list of boards, 5x5 boards. What you need to do is basically draw all the numbers, check each of the boards that you have, and mark the numbers that has been drawn. And as soon as the first board is winning, meaning 5 elements in the row are all been marked, or 5 elements in a column are all been marked, you need to return the sum of all unmarked numbers by the number that was just called. Okay? Let's take a look at the code. Alright, so there's a little bit of parsing here. I'm sure it can be done better, but that's how I did it. What I basically get is the list of numbers in the first line of the input. I calculate the number of boards given the size of the number of lines in the input. So if you remove 1 and divide it by 6, 6 is basically the height of the board plus 1, that is the empty line. Then I loop through the number of boards and I build a board. Basically, row by row, I'm adding the row inside the board. The board is basically a list of int, and the list of boards is a list of int. Okay, so this is the data structures I'm using. You can clearly see that probably creating an abstraction of board would make sense in a real application, but I'm not going to do this here for solving the problem. Let's take a look at the part 1. Okay, what I'm doing is basically I'm calling this function bingo. I loop through the numbers, then I loop through all the boards, and in this first section, what I'm simply doing is basically marking the matches with using -1 as sort of a market number. And then I loop through the boards again, and I check if the sum of a row of a board is -5, means that all the elements in that row are -1, meaning they are basically this is a winning board. Or if all the elements in a column are -1, so the sum is -5, it means it's also a winning board, but basically using a column instead of a row. So if that's the case, I basically return immediately, because this is the first board that actually won, and I calculate the sum of all the elements that are different than -1, so the unmarked element, multiply by a number. And this is effectively the result. Let's take a look at part 2. Part 2 is the same, but what we want instead is keep going and trying to figure out which board will win last. Okay? And then still return the same score at the point when the last board wins. So if I go back to the code, the logic is effectively the same. I'm marking all the elements in the loop at the beginning. I keep track of the winning boards though, and I remove the winning boards after every single round. Okay, but I'm keeping track of the final score. So this score is going to be updated every time there is a winning board. The final score is going to be the score of the last winning board, and then I use the final score to check against the result. I'm actually removing the winning boards from the boards after every draw, just to avoid having to count winning boards multiple times and screwing the result. And that's pretty much it. So this exercise was mostly an implementation problem, and using a data structure to represent your bingo boards, and loop through the numbers and check if the rows and the columns actually are all marked, and eventually calculate the end result. And that's everything. Thank you very much for watching.